Orbital mechanics, also known as astrodynamics, is at the heart of how objects move in space under the influence of gravitational forces. It is the study that primarily deals with the orbits of celestial bodies such as planets, moons, satellites, and spacecraft. Understanding how these objects move is crucial for predicting their paths, planning space missions, and maintaining satellite operations. So what exactly is an orbit? An orbit is the path an object follows as it moves around another object, all due to the force of gravity. For example, the Earth orbits the Sun, and the Moon orbits the Earth. Orbits can be either circular or elliptical, with the latter being more common. In natural celestial mechanics, several key principles govern and define orbital mechanics.
Kepler's laws of planetary motion.
Formulated by Johannes Kepler in the early 17th century, described the motion of planets around the Sun. These laws state that the orbit of a planet is an ellipse, with the Sun at one of the two foci. Additionally, a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time, meaning planets move faster when they are closer to the Sun. Furthermore, the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit. Newton's law of universal gravitation states that every mass attracts every other mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This gravitational force is what keeps planets in orbit around stars and moons around planets. Conservation of angular momentum holds that in an orbit, the angular momentum of a body remains constant unless acted upon by an external torque. This principle explains why a satellite in a lower orbit moves faster than one in a higher orbit. There are different types of orbits that can be classified based on their shape: circular or elliptical, altitude, low, medium or high Earth orbit, at or purpose, geostationary, polar, etc. Each type of orbit serves different purposes, from communication to Earth observation. Understanding these principles allows scientists and engineers to predict orbital paths, launch spacecraft into specific orbits, and navigate interplanetary missions. For instance, adjusting a spacecraft's speed at certain points in its orbit, known as a burn, can change its trajectory, enabling it to reach its destination. In summary, orbital mechanics is the science of how objects move in space under the influence of gravity, and it is fundamental to our ability to explore space, maintain satellite systems, and understand the dynamics of the universe.